This is a very important question, repeatedly asked for the board from electromagnetic waves. The given expression for electric field component of an electromagnetic wave and asking to identify direction of propagation, wavelength, frequency, amplitude of the magnetic field component, and an expression for the magnetic field part of the wave. So before attempting the question, we need to find or understand few properties related to electromagnetic wave, the equation, how we are going to find all these factors. So that first introduction. A basic fact, electromagnetic waves are transverse waves. That indirectly means the electric field component and the magnetic field components are perpendicular to the direction of propagation of the electromagnetic wave. The electromagnetic wave moves at an angle 90 degree normal to the electric field component vibration and the magnetic field component vibration. For an example, if the electric field is oscillating along the positive I cap at any instant, same instant if the B is along plus J cap, so the electromagnetic wave can travel only along I cross J, which is K. So the direction of propagation is always the cross product of electric field component and the magnetic field component. E component cross B component will give you the direction of the propagation. So in this particular direction, the electric field is oscillating up and down like this. The magnetic field is out of the screen and into the screen. So electric field is along x-axis. The magnetic field is along y-axis. So that the wave is propagating along the z-axis. It's clearly representing this particular example. Electric field is along positive x-axis, magnetic field along positive j, and the wave can propagate, move only along the positive z-axis. Now, if we write the equation for the electric and magnetic field components of the wave, the standard equation for both electric and magnetic field component, with the wave traveling along the positive z-axis, E component along the x direction, I cap, and B component along the y direction, j cap. It is E0 cos k z because it's a direction of propagation, minus omega t. The unit is Newton per Coulomb for the electric field. Magnetic field, the unit is Tesla. The phase of electric and magnetic field component always remains the same. That means the function, the angle part for electric field and magnetic field will be always the same. The E0 will become B0, amplitude of magnetic field, E0 amplitude of electric field. The unit, the direction will change. The direction should be in such a way always. Direction of E cross direction of B will give the direction of propagation. It may not be always a cos function. It can be a cos or sine function. So as per the question, whether they give sine function, we write sine function. If they give a cos function like here, we also write the cos function. Instead of, this is for a wave traveling along the positive z direction. If the wave travels back along the negative z direction, this sign kz minus omega t will become kz plus omega t. The sign between kz and omega t will be, instead of minus, will be plus. So if it's traveling along positive z axis, the sign between kz and omega t will be minus. If it's traveling along the negative z direction, the sign between kz and omega t will be minus. That's an important fact to understand how we find the direction of propagation from the equation. Now, there are few equations we should learn. There's a relation between E0 and B0. The ratio of E0 by B0 will be always the speed of the EM wave in that medium. If it's vacuum, that will be C, 3 into 10 raised to 8 meters per second. Then the K is known as propagation constant or angular wave number. It's always equal to 2 pi by lambda. Then omega is 2 pi f, where f is the frequency and omega is the angular frequency. Even you divide omega upon k, omega is 2 pi f, k is 2 pi by lambda. When you divide this, 2 pi get cancelled, you get f lambda. F lambda is v, so v equal to omega by k. So these are the basic equations we need to know for solving the question. Now we are starting with the question. The question is given 3.1 cos 1.8 y 5.4 into 10 raised to 8 along I cap. Just copy the equation. First, we identify these values. For that, write the standard equation we have. It's a cos function. So we're writing cos. So comparing, E0 becomes 3.1 Newton per Coulomb. The K value is 1.8. The omega value is 5.4 into 10 to the power of 8. So K is measured in radian per meter as a unit. Now the first part of the question, what's the direction of propagation? So we just discussed, if the sign between kx, ky or kz, whatever x, y, z with k, plus omega t is plus, that will be along the negative direction. Whether negative x, y, z depends upon this letter. If it's z here, opposite of this sign, negative z direction. So this is also negative but y direction. If it was x here, with plus sign, be negative x direction. So first look the x, y, z component. So here y component. Then look the sign for the opposite of that. So negative y direction is the propagation, negative j axis. That's the first question. Second one, what is the wavelength? For wavelength, we already know the expression for k. K is equal to 2 pi by lambda. You can change the position of lambda and k and get lambda equal to 2 pi by k. So k is already given 1.8. So substitute 2 pi by 1.8. You can multiply 10 up and down. So 20 by 18. That will be 10 by 9 pi. If you calculate, comes approximately 3.49 meters. Now the third one, what's the frequency? For frequency, you already know omega is equal to 2 pi f. So omega is 2 pi f. Get f from that, 2 omega by 2 pi. Omega we already identified as 5.4 into 10 to the power of 8 from the equation. Then divide by 2 pi, we get 8.6 into 10 to the power of 7 hertz as the frequency. Now what is the amplitude of the magnetic field part of the wave? They given the electric field and the amplitude of the electric field component. They're asking the magnetic field part of the wave. So we have a relation between electric field and magnetic field amplitude, E0 by B0 equal to C. The question very clearly says traveling in the vacuum. So no doubt the speed is 3 into 10 to the power of 8 meters per second. So I can substitute for B0 as E0 by C, 3.1 divided by 3 into 10 raised to 1 point something will come. into 10 to the power of minus 8 Tesla is a SI unit for magnetic field. Now write the expression for the magnetic field part of the wave. So as per these two, you can see the only change what happens is the direction will change, the amplitude will change, the phase part will remain same, the unit and the direction again will change. This Y is again indicated by the J cap here. Some cases they don't write here any one of the two, either J here or only Y. So you already know the E component is along the positive x-axis. The question is given along x I cap. That will tell you E component is along the positive x-axis. And direction of propagation we already identified as negative y-axis. So we have a concept, the direction of propagation will be always the cross product of electric field component and magnetic field component. Velocity is along the cross product of E and B. Out of that, E is given as I. B we don't know, but the result should be along minus j cap, because velocity is given minus j cap. So velocity direction is minus j, that we cross product of E with I, and direction of magnetic field we don't know, we need to identify that. So you already know I cross j is k, j cross k is I, and k cross I is j. If k cross I is j, you can reverse it, get the negative. So I cross k will be minus j. So I cross k is minus j. So we compare this, I cross k only will give minus j. That means direction of magnetic field is along k. So the B component will be along z axis. Now we have the equation for electric component. In this, the B0 part will be different. This all will remain same till here. The I becomes what? K, because it's already identified as K. So B will become BZ. So B is equal to 1.3, 1.03 into 10 to the power of minus 8. We already calculated as B0. The phase part remains same, and the direction becomes K. So the Z component.